Hi everyone. Today we have another question of organic chemistry. This is November 2016 paper, and I'm with the question 3. This question is related to the isomerism as well as physical properties of the organic compounds. Here we go. Question 3. The boiling points of 3 isomers are given in the table below. Boiling point, we just need to remember the definition, is the temperature at which vapor pressure of a liquid equals to the atmospheric pressure. Just keep it in mind. Define the term structural isomer. Structural isomers are the organic compounds with same molecular formula, but different structural formula. So here we write organic compounds with same molecular formula, but different structural formula. These isomers, as they have different structural formula, which means they have different structural arrangement, different arrangement of atoms, they have different properties. They have different names, and they are completely different compounds. What type of isomers, either positional, chain, or functional, are these 3 compounds? When we look at these 3 compounds, starting from compound C, we have pentane, we have 2-methylbutane, 2,2-dimethylpropane. As you see, they all end with -ane suffix. So they all belong to the homologous series of alkanes. But the difference between them is the chain structure. Pentane has a straight chain with no branch. Compound P has 1 branch on the second carbon, and the compound A has 2 branches on the second carbon. So basically, the structure of the chain is different here, so that we have chain isomers of those compounds. Those 3 compounds are the chain isomers of each other. 3.3. Explain the trend in boiling points from compound A to C. The boiling point from A to C, how does it change? As you can see, from compound A to C, the boiling point increases. So here we say the boiling point increases. And reason for this, when we look at the structure of these molecules, as I mentioned earlier, compound C has straight chain, compound B has 1 branch, and compound A has 2 branches. From compound C to A, if you go that way, from C to A, the surface area is getting smaller. So as a compound becomes branched, it becomes more compact, so that it becomes smaller in size, in surface area. So we can say from C to A, more compact molecule, or you can say smaller surface area. As the surface area gets smaller, the size is smaller, then what happens? The strength of London forces becomes weaker. So we say from C to A, weaker London forces. As a result, we need less energy to overcome intermolecular forces. Right, so that is it. From C to A, we have smaller surface area, weaker London forces, and less energy required. And as you see, the boiling point decreases from C to A. That's the reason. And the next question says, which one of the three compounds, A, B, or C, has the highest vapor pressure? Refer to the data in the table to give a reason for the answer. Vapor pressure is the pressure exerted by vapor particles, and it's in equilibrium with its liquid, and it happens in a closed container. Vapor pressure is inversely proportional to the boiling point. The higher the boiling point, like this, the lower the vapor pressure, or the lower the boiling point, like the example A, then the higher the vapor pressure. What we are looking for? The highest vapor pressure. So the correct answer is compound A. The reason, lowest boiling point. That's simple, lowest boiling point. Compound A has the highest vapor pressure because it has the lowest boiling point. And lastly, this is a reaction-related question. Use molecular formula and write down a balanced equation for the complete combustion reaction. Combustion reaction, you learned in grade 10, is the reaction of an organic compound with oxygen gas. So here we need to use sufficient amount of oxygen gas, and when an organic compound is burned, it always produces carbon dioxide and the water. So we have two common products, H2O and CO. We are looking for compound B. Compound B is 2-methyl-butane. 2-methyl-butane is CH3, C. Here I have the methyl group, CH3, CH, CH2, CH3. I need the molecular formula here because it says use molecular formula. Molecular formula of 2-methyl-butane is, let us count 1, 2, 3, 4, 5. C5, H, how many? 6, 7, 9, 12. C5, here I have H12. To balance this equation, we need to equalize the number of atoms on the left and the right side. We start with the carbon atom. I have 5 carbon on the left side, so I need to write 5 coefficients in front of CO2. I have 12 hydrogen on the left side, but I have only 2, so I must multiply H2O by 6. And what is left? Oxygen. I have 2 only on the left side, but I have 5 times 2, 10, plus 6 times 1, which is 16. So that left side must be multiplied by number 8. Right now, I have a balanced equation for the complete combustion of compound B. That's all for now, guys. Thank you so much for listening. See you soon.